Okay, so I'm going to go through some of these questions. In fact, I'm going to go through all of them because I just noticed today, with the help of some of the people in class, that the questions and the answer key were completely out of sync. And I've just realised that every time I load up these questions, they move the answers around the place. So therefore, every time I load this up, it gives a different answer key. So I'm just going to go through them now. It might be no harm, in case it's caused any confusion, that you'll see where the answers come from and why the answers are as they are. So we'll start on the first one, which is the bond polarity. 20 questions. Again, only surface stuff, no real depth until you get to the exam questions, which hopefully we'll look at when we go back to school next week. So in covalent bonds, electrons are, well, obviously out of the four, shared. That's what makes a covalent bond covalent, okay? And keep in mind that it really only happens between non-metals and other non-metals. Metals tend to form ionic substances. Covalent substances are formed by the non-metals on the right-hand side of the table. In a polar covalent, now polar covalent means unequally shared electrons. So you keep that in your head straight away. Electrons are shared, and there's the word, unequally. Okay? So whatever option that was in yours, that's the correct answer. Part 3. Which of the following is the correct Lewis structure for water? Now, if you remember me drawing these in class, yeah, we draw the valence electrons, which are the outer electrons responsible for chemical bonding, but when electrons are shared, I join them together by a line. So therefore that one, C, is the correct answer to that. Electronegativity is a measurement of the ability of a nucleus to attract. If you remember the definition, it is the relative force of attraction an atom has for a shared pair of electrons in a covalent bond. So therefore, it is the ability of a nucleus to attract bonding electrons. That's the answer required there. I don't know whether it's A, B, C on yours, not too sure, but that is the correct answer. How many electrons are represented by a single straight line in a Lewis structure? Now, every time we draw a straight line, that's when 2 electrons are being shared. So 2 is the correct answer to that one. The most electronegative atom, top right of the periodic table, excluding the noble gases, fluorine. In this Lewis structure, the symbol above F means, now those little deltas, yeah, that's what they're called deltas, Greek letter D, okay? It means partial. So therefore, above fluorine, we've got a partial negative, which means that the electrons tend to spend more time over there. Not that they're transferred, but they spend more time. So they are basically more attracted to F than they are to H. And that gives you that answer there. In question 8, this is an example of a, well, there's a bond between H and F, but there are delta charges on top. So that is a polar covalent molecule. Question 9. Partial charges like the ones shown here are called dipoles. And I've said that every time you put the partial charges up there, you form a dipole. So the old HF molecule itself, the whole thing is a dipole, because delta negative goes over fluorine and delta positive goes over hydrogen. Which molecule contains the greater polarity? Now, obviously, if we want to work out who has the greater polarity, it's going to be the 2 atoms that have the greatest difference in electronegativity. So it's no harm to say that you should have one of these nearby, and the table of electronegativity values, which is the one immediately after the ionization energies, it's on page 81 of your tables. If we look at the electronegativity of hydrogen, we get 2.2. Now our value is going to be slightly different in our periodic table to the answers here, so we'll see what happens. And then we get oxygen, which is 3.44. So that gives me a total difference of 1.24, which is a very strong dipole. What about OF2? Well, oxygen is 3.44 and F is 3.98, which gives me a difference there of 0.54, which is a much weaker dipole. So therefore the answer is the greater polarity exists between hydrogen and oxygen. However, there's a shortcut. If you remember that when we were going through what we call the 3 types of intramolecular bonding, we had ionic bonds, which are formed by the transfer of electrons. Then we had covalent bonds, which are weak. Then we had polar covalent bonds, which are strong. And then we had the strongest form, which was between H and O, or H and N, or H and F. So straight away, if you look at the first one, the bonding is between oxygen and hydrogen, which is one of the strongest types of polarity we have. Therefore, simply by reason alone and no numbers, you could have dictated H2O. Number 11. Which molecule contains bonds with greater polarity? Now again, we know that HCl is a dipole. And if you want to do it by tables, do it by tables. H, we've already said, is 2.2. Cl, let's put that down. Cl has an electronegativity of 3.16. Okay, and carbon has an electronegativity of 2.55. So therefore, the difference between H and Cl is greater than the difference between C and Cl. See that? So the difference between H and Cl is bigger than the difference between C and Cl. So therefore, that has the greater polarity. In fact, it's a dipole anyway. A bond with a partially negative and a partially positive end is polar. Very straightforward. A diatomic molecule like oxygen is always because electrons are shared something. Now, look at the four answers first of all before you answer anything. O2, as we already know, is nonpolar, okay? Because electrons are shared equally. This is where we get van der Waals forces set up between oxygen molecules. But inside the molecule, between two oxygens, they have the same electronegativity, so the electrons are going to be shared equally, giving you a non-polar molecule because the electrons are shared equally. If boron bonds with hydrogen, a something bond is formed. Now, you can't tell that off the top of your head. You've got to go again back to your tables. If boron bonds with hydrogen, hydrogen, as we already know, is 2.2, and boron, from the table of electronegativities, is 2.04, giving me a difference of 0.16, which is very much in the covalent region. So therefore, it's non-polar covalent. Okay. If bromine bonds with hydrogen, well, let's take a look at bromine. What's the value of bromine? It is 2.96, and again, it's a halogen. So if bromine bonds with hydrogen, you're going to end up with a difference there of 0.76, which puts it very much into the polar covalent region. Because don't forget, on the scale, you've got 0, 0.4, and 1.7. They're the three regions you have to remember. Anything that has an electronegativity difference between 0 and 0.4 is what we call covalent. Anything above 0.4 of a difference to 1.7 is polar covalent, and then we have increasingly ionic as we move up towards, past I should say, 1.7. Okay, bond polarity is determined by calculating the difference between the electronegativities of the atoms forming the bond. Absolutely, that's what it is. Learn the definition. Electronegativity is the relative force of attraction an atom has over a shared pair of electrons in a covalent bond. So therefore, if we're looking at polarity, it's the difference between the electronegativity that tells me how polar or non-polar or ionic that bond is going to be. So that's very true. 17. The electronegativity difference of the bonds of CH4. Now again, just write them down. Go to your tables. Carbon is 2.55. And don't be afraid to do this mathematically. Hydrogen is 2.2. So therefore the difference between them is 0.35, which rounded off 0.4. Which of the following orbital overlap combination will create a pi bond? Now, any time an s orbital is involved, it's sigma. So s can't be involved. So therefore pi will always be between two p orbitals. So we have two options here, px, px or py, py. Now to keep in mind, px, px come in like this. Okay, so there's a head-on collision, which is a sigma bond. Whereas py and py are in parallel, and parallel pi bonds, parallel p orbitals form pi bonds. Write out the electronic configuration of N. Okay, well N is number 7, so it's 1s2, 2s2, 2px, 2py, 2pz. Now I pause there for a moment because I need to think. If it's number 7, I've got 2, 4, and I've got 3 electrons to put into the px, py, pz orbitals, which have equal energy, and that means that we come across who? We come across Hund's rule of maximum multiplicity. Well done. Which says that when orbitals of equal energy are available to electrons, they fill them singly before they fill them in pairs. Which means if another nitrogen comes along, you'll have the same electronic configuration. So therefore, they're not going to be involved in bonding. The bonding will be between an overlap between the px's, which is always going to be sigma, a bonding between the py's, which are in parallel, so that's pi, and the pz's will be in parallel, so that's pi. So the question says, how many pi bonds between two nitrogens? The answer is 2. The electronegativity difference in the bonds of CCl4, well that's 2.25 for carbon, and H is 2.2, So the difference is 0.05. Very, very small. Am I right there? Sorry, 2.2, and that's 2.55. Apologies, 2.55 for carbon. So that gives me a difference of 0.35, and again rounded off 0.4. Okay, so that's the first one done. Now give me a minute and I'll just move to the second one, which is molecular geometry. I will take a quick trip down these questions. Okay, in covalent bonds, electrons are, now there's no harm in having the same questions asked umpteen times. They repeat them in the leaving cert, they're going to repeat them in revision. Obviously covalent means that they are shared. So a little red pen, so they're shared. Okay. What geometry will this molecular structure have? H2S. Now, there is one pair of bonding electrons, so it's a bonding pair. There's another bonding pair. There's a lone pair, and there's a lone pair. So there's 4 pairs around the center. So I expect tetrahedral. However, because 2 of those pairs are lone, it's going to be bent out of shape, into what we would call a V shape, but bent out of tetrahedral shape. So the word there that I suppose most defines what's happening is that the molecular structure has been bent by the presence of the lone pairs. What 2 types of atoms make a covalent bond? Well, as we said, we tend towards the right-hand side of the periodic table where the non-metals are. Metals are on the left and they tend to form ionics. Non-metals are on the right and they tend to form covalents. And noble gases, well, to hell with them, they do nothing unless under big pressure and big temperature, but that's for another person, another day. So the answer is 2 non-metals. Is this a correct dot diagram for fluorine? Well, the number of electrons on the outside of fluorine is exactly the same as the number of the group it's in. So if fluorine is in number 7, group 7, then 1, 2, 3, 4, 5, 6, 7 is correct. The first 3 pair off, and you've got 1 left over unpaired, which actually makes fluorine a free radical. So yes, it's true. Is this a correct dot diagram for oxygen? Well, oxygen is in group 6, so therefore I expect to see 6 electrons around oxygen. This only has 4, so that's going to be false. It's not. Oxygen should be like this. 1, 2, 3, 4, 5, and 6. Choose the correct shape for this molecule. Now, I've showed you this already, okay? The correct shape, take the lone pair down to the hydrogen, across to the hydrogen, back again, and down. What is it? It's a pyramid with a triangular bottom. So if I run a line across there, you'll see the triangle on the bottom, okay? So it's a trigonal pyramidal. Number 7, choose the correct shape for this molecule. Now again, look, there's lone pairs. And lone pairs will always bend the molecule out of shape. So the one there that seems to be the best is bent, which we would call V-shaped, by the way. Yeah, bent or V-shaped. It's perfectly fine. Next one, choose the correct shape for this molecule. Well, flat, triangle. And a flat triangle is a trigonal planar molecule. Choose the correct shape for this molecule. Again, look, no electrons left around the center. So that means we've got another flat triangle. So it's trigonal planar. Choose the correct shape for this molecule. Our favorite. This is our tetrahedral molecule with bond angles, if you remember, of 109.5 degrees. CCl4. Choose the correct shape for this molecule. Well, C is going to be in the middle. You've got Cl, 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 and Cl. So there are 4 electrons around the center of carbon. Each one of those 4 goes and holds a chlorine in place. So there are no spare electrons around carbon. That means that the 4 chlorines distribute themselves under regular geometry, which is obviously, yes, tetrahedral. What is the correct shape of CHCl3? Now, there's 2 rules. There's no electrons left around the center, but not all the terminal molecules are the same. So therefore we are going to get this thing distorting its geometry. So we can, it's not going to be tetrahedral, it's not going to be trigonal planar, it's not going to be it's going to be bent out of shape. Okay. Number 13. Choose the correct shape for this molecule. Well, look, all of the atoms are in a straight line, so it's linear. Question 14. What does it say there? 14. Oh, it hasn't even got a question. I suppose it's asking about the shape of 120. That is most definitely a flat triangle. So it's trigonal planar. According to the octet rule, there's a hint, most elements need 8 valence electrons. Okay, and it says most because there are always going to be people who break the rules and going to be exceptions. Number 16. What molecule could this be? And each purple cloud represents a lone pair of electrons. Well, it's not going to be a CO2 because that's linear. It's not going to be NH3. It's not going to be CH4. So it has to be H2S, because around the center there are only two hydrogens. That's sulfur, and that's hydrogen, and that's hydrogen. So therefore it would represent this one. Number 17 is a center with 3. So the only one that has 3 there is NH3. So that's N, and that's H, and that's H, and that's H. Sometimes these are just done by simple visuals. Yeah, there's a center with 3. So the only molecule that has a center with 3 surrounding atoms is NH3. A lone pair is defined as, now obviously not a pair of bonding electrons, no. One, no, because it's a pair. It's a pair of non-bonding electrons. Number 19, what is the VSEPR theory used to predict? Now, VSEPR, you have to know what those letters stand for. It is the theory by which we assign geometry or shape to our molecules. So therefore, VSEPR has got to do with molecular shape. According to VSEPR, molecules adjust their shapes to keep which of the following as far away as possible? Well, the electrons on the outside of the central atom. And the electrons on the outside of the atom are called valence electrons, because don't forget it's VESPR. The hint is already there. So it's that, pairs of valence electrons. What do the letters? Good, you do have to know that. Valence, shell, that means outer shell, electron, pair, repulsion. That's it. Okay. And that's the last one of those. Okay, now the big one. Now the atomic theory one. Let's go down through these 40 odd questions. But look, no harm. It's revision at the end of the day. So we get stuck in. The positive particles are, well, we should know that. P for positive, P for proton. Yeah? Again, turn on my little red pen. So that one, protons. The central region of an atom where neutrons and protons are located is the nucleus. Particles in an atom that are neutral and have no charge are neutrons. The word atomos. Now, atomos was a Greek word, so I think you can take it. Thomson wasn't Greek, Dalton wasn't Greek, Bohr wasn't Greek, so the only word that's left there is Democritus. This guy proposed that electrons move around the nucleus in specific layers or shells. Now, the guy who came up with the idea of shells or levels or layers was Bohr, after he did his emission spectrum of hydrogen. And remember, for poor old Bohr, it only worked for hydrogen. This picture best represents something atomic model. Well, it looks like a bit of an old plum pudding, so therefore it was Thomson's plum pudding. In Dalton's atomic theory, all elements consisted of atoms. Yeah, we had that word. We didn't say parts or bits, it was atoms. Which of the following is or are conclusions based on Rutherford's gold foil experiment? Now, 3 things. First of all, most of the atom was empty space. Secondly, there was a region, solid region in the middle called the nucleus. And thirdly, it was extremely positively charged. So, the atom is mostly empty space? Yes. The atom has a small, dense nucleus? Yes. The nucleus is positively charged? Yes. In fact, there's the answer. All answers are correct. What is the number of protons that the element in this image contains? The number of protons is the atomic number, which is always the smaller of the two, 7. What number indicates the nucleus? Well, the nucleus is protons and neutrons combined, so number 4. How many electrons does this picture show? 1, 2 in the first shell, 2, 3, 4, 5, 6. So 6. There we are. 2 in the first and 4 in the second. Oops. Number 12. The number in the upper corner of the element tile, 7 for nitrogen, is called, well, we've got 2 numbers. The smaller one is the atomic number that tells you who you are, because that's the number of protons that you have in the nucleus. And the larger one is how heavy your nucleus is. It's the combined mass of protons and neutrons. But the top one is nothing more than not the proton numbers. It's not wrong, but it's not what it's called. It is the number of protons. It represents the number of protons, but it's given a title. It's the atomic number. Number 13, like my beard. If an atom contains exactly 3 protons, then it is an atom of, well, 3 protons means you're number 3 in the periodic table, hydrogen, helium, lithium. That's why you should really know the first 36 elements off by heart. Still haven't examined that yet. Leave it till after November exams. For an atom to be electrically neutral, it must contain the same number of... Now, the two parts that have a charge are protons and electrons. Protons are positive, electrons are negative, and if you've got the same number of both, the atom is neutral. So therefore you want the same number of protons and electrons. Which part of an atom is used to identify it? Well, the number of protons, because the number of protons is your characteristic identification. How many neutrons in this species? Well, it's the difference between 238 and 92. 238 is the combined mass of the nucleus in terms of protons and neutrons. 92 is the protons. So if you take them away from one another, you get 146. According to Bohr, according to the Bohr model of the atom, light is emitted continuously as electrons revolve? No. Light produced due to repulsion? No. Light is released as an electron moves to a higher level? No. When electrons are moving up, they're sucking in energy. Light is released when an electron drops? Yes, because when they fall down, they've got to give the energy out. So that one there is the correct answer. An atom has 14 protons, 15 neutrons, and 14 electrons. Its mass number. Now, the combined mass of the nucleus is the number of protons and neutrons, which gives you an answer of 29. What charge is the ion formed from an element Z likely to have? Now, in order to work out the charge of element Z, you have to have a look and see how the 7 electrons are distributed. 1s2, 2s2, 2px1, 2py1, and 2pz1. Okay, in fact, it's nitrogen. So therefore, the px, py, pz want to gain 1 each. And when they do gain 3 electrons, don't forget, that means they're going to take on more negativity, which means they're going to become 3 minus. It's nitrogen, actually. And it's in group 5 as well. So you could look at it in group 5 and say, okay, element number 7, nitrogen, group 5, nearest noble gas is neon. Neon is 3 steps forward, has to gain 3 electrons, 3 minus. Which scientist performed the gold foil experiment? Rutherford's gold foil experiment. Just learn the name, and learn the name of the scientist involved in the experiment. How would you write the isotope name for this nuclide symbol? Now, the isotope name is the symbol with the mass. So this is sodium 23. 11 is just number of protons, never changes. What do these isotopes of carbon all have in common? Well, what do isotopes have in common? The only thing they don't have in common is their number of neutrons. So therefore they've got protons in common and they've got electrons in common. Is that there anywhere? Yep. And don't forget, atomic number means protons, doesn't it? That's what it is. So there it is. Protons and electrons. 23. How many protons are in the following atom? The number of protons is the same as the atomic number, which is the smaller of the two, which is 82. 3 isotopes of carbon have different what? Well, isotopes always have different numbers of neutrons. And that means that their masses will be different, so they'll have different mass numbers. What is mass number? Well, the mass number of an atom is the combined mass of protons and neutrons. So you can take the average atomic mass. Now that's interesting. Stuck between these two. But I wouldn't go for the first one because it's not the average atomic mass. It's the average mass of all the isotopes of a given element, taking into consideration their relative abundances, compared with 1/12 to the carbon-12 isotope. I know, I show off. Oh well. It's not that one. It's this one. The mass number of an atom is its number of protons and neutrons. 26. Which of these pairs of atoms are isotopes? Oh, God help you. I didn't realise it was so small. Hold on a second. Let me see in there. So say, which pair of these atoms are isotopes? Which pair are isotopes? Well, the protons have to be the same, so they're not isotopes. No. No. And yeah, that's it. So pair C. That's it, pair C. How big did I get there? Pair C. Yeah, this one, pair C. Number 27. What is the correct hyphen notation name for the isotope with 19 electrons and 21 neutrons? Now, bit of a trick there. If you have 19 electrons, that means you also have 19 protons. Yeah. The number of protons together with the number of neutrons gives you the mass, which is also part of the name of the isotope. So 21 and 19 is 40, and we're dealing with 19 electrons, 19 protons. So that's the 19th element on the periodic table. So the 19th element is potassium, so therefore it's potassium 40. 28. 24.1 of all the isotopes of an element have a mass of 75.23. 48.7 have a mass of 74.61, and 27.2 have a mass of 75.2. What is the average mass of this element? Now, let's take a look and see. So, if I do this correctly, 24.1 multiplied by 75.23 plus 0.487, because don't forget percentages, you bring the decimal point back 2 spaces. So actually I should have said in the first one 0.241. Let me just do that again. 0.241 multiplied by 75.23 plus 0.487 multiplied by 74.61. I better put brackets around that because I want that to add on. Okay. And lastly, plus 0.272 multiplied by 75.2. And again, let's put brackets around that because we want them to add on. And if I've done that correctly, 74.919. So therefore the answer is 74.92. So the way to do it is you multiply the mass by the abundance. Now the abundance is always given in a percentage. So you have to remember, if it's given to you as a percentage, so 24.1% multiplied by 75.23, I would put that into the calculator, not with the percentage symbol, but I would move the decimal point from there, and I would put the decimal point there, and I'd multiply 0.241 by 75.23. Then you do 0.487 multiplied by 74.61, and lastly 0.272 by 75.20. Okay, and then you just add them together and you get your answer. Next one, 0.0435 multiplied by 39.946. Okay, 0.8379 multiplied by 41.941. They're not making this easy for anybody, are they? 0950 multiplied by 42.941, and 0.0236 multiplied by 43.939. Okay, now if you put all them together, I do this earlier, I think I might have. Instead of do all that my calculator, let's just get the answers. No, I didn't. Marvelous. Have to do it now. Okay, let's do it quickly. 0.0435 multiplied by 39.946. Okay, plus 0.8379 multiplied by 41.941 plus 0.095 multiplied by 42.941, and then lastly 0.0236 multiplied by 43.939. Now if I've done that correctly, I get a syntax error. Let's try it again. Right. 0.0435 multiplied by 39.946 plus, now I forgot to put my brackets in, I think, 0.8379 multiplied by 41.941 plus 0.095 multiplied by 42.941, and finally plus 0.0236 multiplied by 43.939, and we get an answer of 41.99, which is exactly that one. Good. Not another one, please. Compute the average atomic mass for this element. Okay, here we go again. 92.22, so 0.9222. 27.977. I'm trying to make sure you have good eyesight, making these things so small for you. 4.69, so that's 0.0469. multiplied by 28.976 plus 0.03 multiplied by 29.974. And that comes out at 28.08. There we are, 28.085. So that's the nearest one. Okay, the average mass cannot be determined. Of course it can, because once you have the mass of the isotope in relative abundance, you multiply the two, add them all together, and that's your answer. What charge does an atom have when it gains electron? Well, if you gain electrons, you become more negative, so therefore the negative charge. What subatomic particle changes in an ion? What forms ions? The gain or loss of electrons. When an atom gains a valence electron, it becomes a negative ion. Okay, because when you gain electrons, you gain negativity, so you become negative. I've just copped onto something here, 34 and 35. You didn't have colour. You had black and white. Anyway, let's do them now. 34. Where are the metals located on the periodic table? Metals are located in the blue area, that big area. Number 35. Where are non-metals located? Red. Okay, the red area are your non-metals. Anions are, now we studied these, we did all the chemical reactions, chlorides, sulfates, sulfides, carbonates, hydrogen carbonates, nitrates and phosphates. If you noticed, they were all negatively charged. They're all anions. So anions are negative. What's a cation's charge? Well, if an anion is negative, a cation must be positive. Is potassium a cation or an anion? Now to answer that, you've got to go to the periodic table. Potassium is in group 1. It wants to have the same number of electrons as argon, which is one behind it, so it's going to lose an electron, and if you lose electrons, if you lose negativity, you become more positive, so therefore you are a cation. 39. What were Ernest Rutherford's 3 contributions to atomic theory? Number 1, all atoms, 99% empty space. Number 2, all atoms have a very dense positive nucleus. Yeah. And number 3, those dense positive parts are called protons. So, did he discover the atoms one? Yes. Did he use cathode rays? No. Did he discover that the proton? Yes. Did he discover the nucleus through the gold foil experiment? Yes. And did he discover? No. So 3 were correct. He discovered the atom is mostly empty space. He discovered that the proton had positive charges, and he discovered the nucleus because he did the gold foil experiment. Which one of these is Dalton's? Dalton said all atoms are what? Solid indivisible particles. Well, the only one there that looks solid and indivisible is that one. Which model was created after the discovery of the electron cloud? Well, the cloud gave us exactly that. A cloud, a fuzziness of where the electrons are. We can't do that because that tells us that electrons have defined paths. They don't. We know that electrons, we have a probability of finding an electron in an orbital. Remember that? Yeah, Heisenberg's uncertainty principle. So that means this one is the best. And then lastly, whose model is this? Well, that's Thomson's plum pudding. Which statements are true about isotopes? Sulfur 34, sulfur 33, sulfur 32. There is an equivalent amount of each in 3 and no. Isotopes are present. Isotopes of an element have different abundances. The abundance of the 3 varies in nature. It's not the same percentage of each. Yes, correct. They have different numbers of neutrons. Absolutely. That's what makes isotopes. Sulfur 34 has 2 more no. So just those 2. Now again, they're in different places on your sheets. Apologies for that, but just make sure you have the same 2 answers as me no matter where they are. An element has 2 naturally occurring isotopes. Okay, let me just see if I have these done, because I think I do. I don't want to be doing more calculations and wasting your time. I do. Great. Okay, so what do? 1 is 10.013 AMU and is 19. So you've got 0.199 multiplied by 10.013. Then you have 0.801 multiplied by 11.01. You then, that's it. And when you multiply those and add them together, you get 10.81, which is boron. Okay. And finally, 4.35, so 0.0435 multiplied by 39.946. 0.8379 multiplied by 41.941. 0.095 multiplied by 42.941. This seems very much like a question we did earlier on. I must have repeated myself. 0.0236 multiplied by 43.939. When you do all those in your calculator and you add them together, you get 41.97. Look, again, apologies for having your answers in different places on your worksheets, but will you go through the worksheets now with your answers according to this video here and make sure that you have the right answer. No matter where it is on your sheet, make sure that your answers correlate with mine.